and also we are joined by Oguz, who's also a professor.
Hello,
So,
everyone.
yes, so Brian, you have the microphone, sir.
Thank you. So today I kind of wanted to change things up a little bit. Previously I had been kind of, giving some presentations and covering some of the more theoretical background. Like a couple weeks ago, we covered how geomedians are created. And last week we talked kind of in general terms about drone data collection. So today, and then we also had a very nice presentation on the new Geomad's product that's available on the Digital Earth Africa map. And so let me go ahead and share my screen. And I thought we would kind of cover some of the tools to kind of duplicate what's going on in the Digital Earth Africa map and kind of make this a little bit more interactive and duplicate that in a Jupyter notebook. With one of the tools that's very, very nice. So if you want to go ahead and start if you have a computer in front of you, you can go ahead and start navigating towards the sandbox, because that's where we're going to eventually end up. And we're going to end up in the frequently used code folder. But first, this is the map that we went over last week, and we were looking at the new Geomad product that's available. And if you want to also navigate along, you can go to maps.digitalearth.africa, and you can go to the surface reflectix products. I should make sure I have chat up so I can see. Feel free to interrupt me or ask a question or anything like that. I'm very, very open, because this is for you to learn and for everybody to kind of be on the same page. So there are no stupid questions. All questions are very good and welcome. So please let me know if you have any, or if I'm going too fast, or something of that nature. So under the surface reflectance, we have the annual Geomad, and we can hit the plus button. I'm actually going to remove that. You can hit the plus button here to add it, and this should come up over on the left-hand side. And in the Geomad product, you have lots of different options. And one thing we might want to look at, for instance, is water extents, right? So we have, for instance, we could look at geomedians like we did. This was what we recovered a couple of weeks ago. This is already nice and pre-computed here, and there's actually two different versions, one with the red, green, and blue, and one with the shortwave infrared, the near infrared, and the green. Sometimes they call that like natural color and like true color. That's kind of a semantic distinction. But let's say, for instance, and I know there's been a lot of interest in this, for instance, water extents. And so we could actually go to the normalized difference water index, or NDWI. The MNDWI, the modified normalized difference water index, is also available here. And for instance, maybe we want to look at a body that we're concerned about, let's say like Lake Chad, and we can zoom in and we can see this, right? And this button right here, right, will pop up the, just as a refresher, will pop up actually the time series of data. And it might take a little bit to load, but once it does load, you can actually watch the time series. Somebody have a question?
No question, Brian.
No? Okay.
It was a wrong mic.
Okay. So we can see this time series of the water extents, and they're actually quite constant, which is good, right? But let's say I wanted to have a time series in make my own time series, make some sort of thing I could maybe put it into a presentation or something like that, or even be a little bit more analytical about it and get my hands on it. So I can actually get access to the same thing um, uh, on the sandbox. So the if you go to so here we are in the sandbox, and we go to the frequently used code folder, right? I know this folder looks a little bit more full than y'all's because I end up creating a lot of notebooks for this presentation and for my own use. But the frequently used code folder is chock full of like very useful notebooks that cover kind of things you might want to do quite often on the sandbox. And one of these notebooks that I want to point you to is the animated time series notebook. And I've modified this notebook a little bit. So I'll walk you through what I've changed. And these changes might be like very common changes that you might want to make. And we'll kind of go over what this notebook is illustrating and what you can do with it. And it's gonna let us kind of have this time series data that we have in our maps here and give us access to it in the notebook, so we can really dig our hands in and manipulate it in a very granular way in a Python environment. So up here is just kind of a boilerplate explaining what this notebook will do. There's kind of 6 parts to this notebook. We're going to focus on just the first few parts, and if there's interest, we can go over the other ones, but kind of in the interest of time, I don't want to bore everybody to death. So the as always, we start out by importing the core kind of libraries we're going to need in order to manipulate the data. And then we're also going to import a few scripts that are commonly used on the sandbox that are kind of useful. One of these I've added, which is display map, because we're going to be changing the location here. So go ahead and you can go ahead and run this. And convenient shortcut is Shift Enter, right? I'm sure most everybody knows this, but if you don't, it's very handy to have. So we set up our data cube, right, by creating the data cube object here. And then in the loading the satellite data from the data cube, let's go ahead and change this to the same location we were looking at in this area. And this is actually quite easy to do, because let's just kind of choose an area in here. And if we look down here in the bottom right-hand corner, we have a little lat long, right, that we can, that is actively reading out the location of our cursor in latitude and longitude coordinates. And we can go ahead and pick a location that seems nice and plug in 13 and 14.3 for Lake Chad. And here's one of the things that I've changed, right? Like, so besides the location, I'm sure, it's kind of obvious, like, yes, you would want to change the location. But one thing you may want to do is change the extent to be very, very large, right? And I think a lot of people get into trouble on the notebook because if you look down here in our bottom right-hand corner, we only have 15 gigabytes of memory. And because the data we're loading has, keep in mind, each pixel has like, oftentimes we're loading many different multispectral bands with that. And we're loading a time series, right? Even though it doesn't seem like such a big area, like in a, the picture doesn't seem that big, because it's only like, maybe, 500 pixels by 500 pixels or something in that range, the few hundred pixels. That doesn't seem like a big image, but because we're doing it throughout time and we have so many different bands, the amount of data multiplies quite quickly, and we can very easily run out of memory. So in order to load a whole degree here, so I've set the buffer to be about 0.5, and so from this central location, I'm subtracting the buffer and adding the buffer on one side, and then I'm doing the same thing in the vertical direction, right? um, I have like a full degree of imagery I want to import. And the way I do this is also by using this resolution parameter. And and here I am telling it that I actually want the pixels, instead of, this is Sentinel data, just like what we were looking at in the maps, where it's normally a 10 meter by 10 meter pixel. What I want here is actually a 90 meter by 90 meter pixel. I just actually kind of guessed at that. But keep in mind, every time we like half the resolution, right, we're actually quartering the amount of data that we're going to need, right? So, which is very so. So if we go from a 10 meter to a 20 meter, right, like that's a quarter of a data, and if we go to the 10 to the 30 meter, that's going to be like a ninth the amount of data. So, it's very important to get comfortable with this, and this is really nice because it actually never gets into memory. The data cube itself will resample it for us. And so here I'm using the display map script, to just make sure I'm in the right location, that my location is kind of framed the way I would like. Yeah. And then I go ahead and load my data from the data cube. And I also adjusted this min good parameter because we are loading such a big area. I actually, cloud cover will actually be like relatively smaller. And just to make the data loading faster, because there is actually going to be a lot of resampling on the back end to make these larger pixels. And the reason I ran this ahead of time is this does take, I know this is kind of frustrating, but this loading this amount of data won't be as big, but it still takes quite a while, right? And when it's done loading up, I have 35 time slices and a very large area in my X and Y. But it's not taking up that much room because it's much lower resolution. All right, then I actually want to do something kind of different here, because let's just say I had my original data set that comes out of here. I'm renaming it to old so we can look at the differences in just 1 second. But when you first load your data, you might want to get a look at it, right? And so let's take a look at the original data set, which I'm calling old here. And we'll run this. And we'll notice we have a problem. Whoops. Oh, I actually messed this up. But one of the problems we'll notice is that when we look at our time slices here, right, is that the extent is actually so large that in the Landsat data, remember the Landsat data is like collected from orbit, right? So on each orbit, it creates one pass and another pass, right? And there's a slight overlap between these two. And if we get a large enough extent, or we just happen to be unlucky enough, right, the area that we're trying to observe may actually encompass two of these passes. And so the problem here is that we can see that we have, even though we have a lot of time slices, right? This is October 11th, right? And this is October 14th. Those are only 3 days apart, which actually tells me, this should give me some indication right away that I actually have a kind of like a problem with the data, which is that I'm actually capturing two path rows that are right next to each other. And this is going to cause kind of a problem in the data. And what I'm doing here, I wanted to illustrate it to you, but in my toying around earlier, I accidentally overwrote the old data set. Is that in order to combine these two path rows, so that when we're doing the animating in a second, so it's not flickering, we need to combine the two. So Xarray has a really nice method called resample. And here I'm telling it resample along the time dimension, and I want to resample with a frequency of 1 week. So if these two images, so the idea is that any images that were captured within 1 week of each other, I want to combine into one image, right? With this method here, with the mean, right? So I want to take the mean of any images that were captured within 1 week of one another and combine them into one image. And that's what creates this nice image where we would normally have an overlap. I'm actually going to start this. Actually, I'll try to illustrate the problem at the end. But after I do that, this data set will actually, it actually looks really nice. And you can still see some artifacts from the two path rows being next to each other in the RGB data, which is that, like, for instance, this line here is the line of the two path rows. Notice there was a cloud, because these were captured on two slightly different dates. And so there were clouds in this path row, but there weren't clouds in this one. And so there will still be some of those artifacts. There was like a lot of clouds here, apparently. You can see the same artifact showing up here. But now at least I have a complete picture of the, was asking if someone can change the time of the animation frame. Yes, you can. It is a little bit fast by default. And let's say you had a question like that on your own, right? So what we can do actually is that, keep in mind that these are just scripts, and they're just Python scripts that live on the data cube. Sorry, there was a question in chat. So if somebody, I should state for the video and everybody else is that somebody was asking if you can change the time of the animation frames, right? And so if you had a question like this about the XR animation script, right? Here we're importing it from DE Africa plotting, right? And so I can actually go into the DE Africa plotting script and just open it up right here. And it says here, and then it'll tell you to make sure you're in the right spot, right? These are the functions that are included. And so I want to scroll down to the, it's going to be the last one, most likely, and the XR animation here. And just this is where this function is actually defined, right? And there's a nice little documentation here, right? And it actually just describes all the different parameters you can give to this function, right? And so what you're looking for here is actually this interval parameter that you can feed to the XR animation function. Hopefully that answers your question and allows you to answer future questions if you're so curious. And you can see how all of this is done. You can actually read how the animation function is implemented here. Is that good? Hopefully.
Yes, I think that's great. That was noted that it's in the DE Africa scripts, DE Africa plotting, and it was around a line 538. So I was trying also to follow.
Yeah, sorry about that. And sometimes it's easier to open up these scripts because they are quite big files. It's just to, you can hit Control F, and then you can look for like XR. It was underscore animation, right? And then there's the first instance, and the second instance should be the actual definition right there. So, okay. Resuming back.
That was line 534. I was just following up on their behalf. It's 534 on that particular script.
Excellent.
Thank you.
Okay. So we have the RGB images, and then so if we wanted to vary the time this took, right? So let's say we want 500. I believe it's in milliseconds. You can look at the documentation again. We can go ahead and generate this thing, and I will give you that the And so this is going a little bit slower. We might be able to see the changes a little bit more. And this is just RGB. And one thing that we can actually see is there's actually some creeping green in the southern portion, right? That the green area is actually expanding. It's a little bit harder to see the water extent. So you can also designate a different set of bands in the data set that you actually want to see. And again, we can go ahead and run this again. I should have cleared the outputs beforehand. It gets rid of some of the suspense, I suppose. But and we can see here that, and one reason to look at it in this what is confusingly called natural color, but right, is it's a lot easier to see the difference between water and vegetation. The water is a really electric blue, and the green is really a vibrant, like, neon green. And we can actually see that the over time the water is increasing slightly, but the green area is actually quite rapidly expanding over the time that the Sentinel imagery was taken. And here, we can do the same with a single band. We've defined a new band here in the data set, right? The NDWI. You could use the calculate band indices script to do this, but this is just kind of laying it all out here. And again, this looks a little fast, so I'm gonna change the interval to be 500 again. Gotta remember my comma, and I'll run it again. And so that's a little bit slower and a little bit easier to comprehend. We still have some cloud cover, covering this. And here, this is all nice, but we want to actually adjust the way this picture looks, right? That this is not really conveying that this is like water in what we're looking at here. So I may want to adjust the color scheme, and I may also want to highlight just the water, right? So I can actually pass what's called the mshow keyword arguments. That's what the keyword args stands for, as a little dictionary here. And this is basically saying I want the color map to be blues. I want my min to be, so I want, like, in the color scale, I want the min to be 0. Because if we look up here, this color bar is going from negative 7.16 to 0.74, right? And here I'm changing the scale of the color bars, right? So I'm going from 0 to 0.5, and that's defined right here, right? And I'll run that again, and it'll do this. And we're doing this all without running out of memory, and doing this over a very large extent just by downsampling, because sometimes we want to see kind of a large area, and then if we have an area of detail, we can use the full resolution imagery once we go to kind of like a smaller area. And here, this next one shows us how to actually export the same animation as a GIF, or GIF, or however you may pronounce it. And that's really nice when we may want to take this and put this into a presentation, or email this to our colleagues or something like that. And so if we go back, so if we run this here, actually I'm going to change this again. So feel free to use these notebooks as kind of like a jumping off point, and change, really play around and change with the values. So we'll make a slower version, and we'll actually go. So this is going to pop up in the place where we run the notebook, right? So we need to go back. I need to go back to the real world, not real world examples, frequently used code. My apologies. And we have this animated time series GIF here, and this is now reflecting on my changes. And this is a file I can download this file, or or send it off or something like that. So and then another output format. So this actually preserved my changes from earlier, where you can see that this path row was actually causing kind of some problems, but we can actually output this as an actual video as well, which may be preferable because videos tend to have better compression, and they load better in the browser. One thing is that when you open this up, Jupyter Lab will actually yell at you when you try to open it as a video. And so it's basically saying this is not UTF. It's basically saying it's not a text file, or an image. So I don't know how to open this. And so what you need to do in order to view your output is you can right-click it and then open it in a new browser tab. And then here we go. We can see our animation, right? And we can actually scroll back and forth in the animation, which is kind of a nice feature compared to a GIF. All right. So there's more here about adding vector overlays, but because we've changed the location, this doesn't work because we don't have actually vector data for this area. But I encourage you to go back and look at the original notebook. It's very nice looking. I would say that there is kind of this interesting thing you can do here where you can actually apply custom image processing to it as well. But I think both of those are kind of more advanced concepts. And if you want to know how to generate these contours, there is also another notebook over that. And if there's interest, we could go over that in another session. Yeah, so just to compare, we have the NDWI here. Two things to note: that it is cloud masked in this instance, so we're masking out the clouds, and that's for data processing integrity. But this looks quite similar to our actual animation here. I can't actually speed this up, but it should, it changes each year for each of the years here. So you can produce similar looking outputs in the notebook from what you get. That is, what advantages is that this is pre-computed and I can scroll, all over Africa, wherever I might be. And it's all pre-computed for you. But if you really wanted to then do your own analysis off of this, the notebooks are here for you and you can duplicate that kind of thing. Yeah, I didn't see any more questions, so I don't think I have much more to cover unless anybody else has a question or a comment.
So thank you very much, Brian, for this great presentation. This is something we can actually relate, and I think some of our members in this group are thinking about various examples. We can just give them a minute to pause and reflect on this. Edward, did you want to add something, sir?
No, Ken, I think this is a really great presentation.
Thank you, Edward. So everyone is a go. Maybe just to give you a small taste is that you could, on the same notes, try something for someone in this call because they have really sacrificed their time and they are calling from far. And this is just more of a reflection on the Okavango. This should be I'll just put the text on the X and longs that you could actually just try on your side. Brian.
Okay.
So
yeah.
Those are coordinates from Google. So I think that is the lat long.
Right here. Let me share my screen again and we can do this together. All right, let me open up chat now. Sorry, got to get all my windows arranged here. So where did my chat window go? I have lost. When I shared my screen, it seems to hide. There it is. Okay, excellent. So for our lat.
And long.
Yeah. So
it's 19 degrees south.
I'll say it's no longer Lake Chad, so let's not leave that. That would be confusing to me. Is this the area you were hoping for?
Yes. So the whole Okavango, as we had discussed earlier on, is quite a big area, and it's quite of interest.
So
Professor.
Right. So that's not. Yeah, that's not quite the whole area. So what we can do is we can increase the buffer size here, right? And let's see what 0.6 gets us. And do we want to move, you know, well, let's just see what happens when we increase the size. Maybe a little bit more. So now, I mean, that should be okay for now, I guess. Enough for doing it live. And so this would take. So I mean, if we really want to see this, this is going to take a while. And this is kind of one of the downsides of the upsampling method that I'm using here. Or sorry, downsampling method that I'm using here. But I also should have done another step before I started this, but I think it should be okay because we're only at 5 gigabytes of memory. Is that before I load in a new one, right? Keep in mind, I've run all these cells down the notebook, right? And that still keeps all of my Lake Chad data sets in memory, right? Until I end up overwriting them. So right now I'm actually kind of having 2 analyses in memory. So it's important to kind of, I know it's a little bit of a pain, but if you go up here to run and you hit, restart the kernel and then run the cells again with the new location, right? This will be it. The other thing I could have done to kind of help me give me an idea, since I don't think we're going to want to wait on this the whole time. Maybe, I don't know. So one of the problems is I'm actually in this kind of waiting game. And one thing is you can actually start a Dask cluster. And there's this nice Dask dashboard over here that when you start the cluster, load ARD in the background. It's doing something kind of complicated. And I know we gave a presentation on Dask previously, but you don't really have to really understand what it's doing. But it has this nice little progress bar thing that you can actually monitor what you're doing in the background. So yeah, because this is such a large area, this is going to take, I mean, the original thing I think took me, I timed it to be about 10 minutes to load. And but once it's loaded to the notebook is very responsive, as you saw. So yeah.
So don't worry, Brad. This was meant to be a tough assignment so that keep you busy as we wait for more questions. The opportunity here is just to see what is possible, because most of the stakeholders in this room are working in bigger areas. Some are working in small countries. So it's just the variability, and it's very nice that we have this to compare with. And also maybe the same you could just display on the DE Africa map, on the Geomad, as we wait for this to finish.
So one thing to note is that if you're like wondering, like, did this crash, did this not crash, right? You can see your memory filling up here in the bottom left, and that means it's slowly processing and downsampling. So maybe help me with the spelling here. Okavango is, I don't actually, no, that doesn't seem right.
It's a natural, as I put it on your chart, for everyone to appreciate the diversity.
Yeah, thank you.
Just to South Africa.
No, I don't want to. Sorry. And so I think this is maybe zoomed in a little too much.
Yeah, it's around the area.
Yeah, since it's such a large. Here we go. There we go. All right. And then done. And then we can, this should be bringing up the, we're still playing. So notice it was still playing this. So we may want to look at MNDWI, same area. This will, you can see there's actually a kind of a very subtle progress bar in the top here. I'm gonna just kind of check back and see if this is done loading. Okay, this appears to be done loading while we're doing that. So
Maybe also as we look for the area, actually it's around Maun, this area, it's towards the slightly northwest. You'll see the variability of the towards the, so you're inside the northwest of Botswana, and once you head a northwest, you'll see. Maybe just as these one loads, could it be an issue of your internet as well as the memory of your laptop? Maybe just as a guide, because we are in this group together. Some might want to know if you increase your graphics card, does this really help?
Unfortunately, no, because this is actually running in the cloud, right? So the idea is that this is supposed to be quite accessible from any sort of machine. You can run the data cube locally, but this is not going to. Your internet speed will, will affect how fast these tiles for the map will load into your browser. But all the processing is being done on the back end. So I'm actually not totally sure if we have full MNDWI coverage. We obviously have the geomedians here, but we can go back to this area. So we've loaded the data, right? And we'll take a quick look at it real quick. So we have 36 time slices, right? And then when I downsample it, I get about half the time slices when I resample it at the week threshold. And then we can look at the RGB here. It'll take 1 second. So yeah, patience is kind of the name of the game when running some of these cells. So this is to just give me the idea. This is taking the first 8 time slices in the image, right? And then if I wanted to, and I guess I might actually be able to illustrate the difference between the original data set and the resampled data set here, if I run this one more time. Yeah, I just think that there's not a lot of water detection going. I know there is. The map is indicating that there is water, but for instance, NDVI is here, so we'll actually see what this picks up when we run our analysis. Okay, I'm gonna interrupt that. We are getting a little bit low on memory, but and you can see it's yelling at me down there. This is why you kind of need to, every time you start an analysis in a notebook, it's a good idea to kind of like clear out the kernel. And so this is just telling me I interrupted that thing. But let's see if we can produce an animation real quick of the Okavango.
So I've tried to do the same with the maps and the WAFs. It gives you some comparability of the area in terms of just in case you want to open that link on the chat, you can actually see there's some changes over time, and this is what has been observed by Kelaboge over time. There's some years they had a drought in the area, and there's a time there's floods around the year 2017. So it's more of looking at how we can look at big areas, assessment of natural resources over big areas. I think also this would be of interest to our colleagues from AfriGist. Looking at the whole of Nigeria, there's a lot of things they can look at. And since they are on this call, they can also give us an example of what they would like to do. But I think this gives you the value that we really want everyone in this call to be engaged.
Yep. Are there any other questions or? Yeah, I ran out of memory, so I kind of had to. There was no way around it. I had to restart, unfortunately. So, yeah, make sure every time you run it. So, like, even though it is smaller, right, we are still taking up a substantial amount of memory, even when we're running over these larger areas. So that was my mistake.
How about if you shut down some kernel sessions that you don't require so that
Yeah.
could
Well,
it
so
also...
notice when I shut down the notebook itself, right, I've dropped back down to just a couple of gigs, right? And we can load this back up. That stuff, that is very fast. This, again, is going to be a bit of a time-consuming step. So, and one way around this is that if you do get into the area that you're kind of, let's say, constrained on memory, right? One trick is you can actually use the magic store, which will actually, so this will actually, so you have a certain amount of storage on your account for the sandbox, right? And this will actually write, so whatever it is, it will actually write it to disk, and then you can, when you want to, so it'll write it to disk. And so let's say I'm low on memory, I kind of need to restart everything, but there's like, I have some data that went through some time intensive steps beforehand. I can store whatever variable it is, right? And then when I come back to the notebook, right, I can then read that back from disk. And this is without having to save it to a file or anything like that. And I can just do the store retrieve thing, and it will restore this variable with its previous data without having to go through the kind of time varying thing. I didn't know what I actually really got like that last time, so I didn't really want to necessarily do that, but that's the strategy. And so, yeah, so the difference between this and waiting for this to load and this is that all of this here is pre-computed. So some very nice people at GA have taken the time and the computational resources to run each one of these different indices over the whole continent, right? And so when you're actually loading the data here, you're loading up a pre-computed data set. Whereas in the sandbox, every time you're requesting data or you're running something, right, it's actually crunching the numbers for you every time at your request the way you tell it to. And that's really where these like kind of very the big time differences come in. And yeah.
So thank you very much, Brian. I know maybe things might we went beyond, but the example was to have everyone understand how this is possible. And also, since everyone is on this call, they can advise us maybe the next topic that they want to see. So members, this is your time to propose another topic for next week. I know this one was nice from the look of things, since everyone is quiet, they are just maybe going through what we've seen. So anyone else has a topic for next week or has a question for us? So for example, have you had a chance to explore the Geomad? You can see it gives you an opportunity to look at things much faster without even exploring the notebooks. However, both are complementary resources for us to use for any type of work and research. So mine is to thank everyone who's joined us for the first time today, especially our colleagues from AfriGist. Thank you very much for making the time. I also need to appreciate Monsu Mahamani, calling from Agreement, Niger. Welcome so much, Monsu. How are you today, sir?
Thank you, Kelly. Thank you.
I hope the session was informative, as you can help us more information on Lake Chad and the other resources in Nigeria. Amadou Sal, are you there with us? Do you have any updates for us?
Yeah, thank you. Good morning, Ken. Thanks.
Welcome, Amadou. Welcome, sir. I also have John Kisangao calling from Calro. How are you, sir, today? I hope you're well. Also, we have many colleagues who've joined, including Herbert. How are you, Herbert?
I'm fine. I'm doing well. Let us try ourselves. When we get problem, we let you know.
Thank you
We
so
have
much.
to try it first. It's when we are trying that we know that there's also a problem. So let us try first.
Yes.
And on our way, when we get some issues, we come and let you know.
Thank you so much. Ours is to appreciate everyone for making the time for this call. And we can look at a topic for you next week, possibly something on various deforestation or et cetera, or you can always reach out to us and give us this topic of interest. I wish to ask Stella if she's there, she can greet everybody.
You're on mute.
Hi, I'm well. Yes, just busy with school and exams, but I'm well, and it's glad to see your presentation on Geomad. Yeah.
Thank you so much, Stella. We also joined by Joyce Yundu. How are you, Joyce, today?
Fine, thank you, Ken. I'm doing well.
Thank you so much for joining us. I think Brian on the chat, Kelaboge has mentioned something about the flooding extents, the times, the May, September, something we can explore as we continue to work with her for the Okavango. Thank you so much, Kelaboge, for making the time to join us. And everyone, thank you so much.
Thank you.
I think someone asked if there's a notebook available for this. Yes, Soma. We are looking at Brian was showing the example from the frequently used codes notebook, and also possibly, Brian, if you had yours, you could export your notebook and I'll put it in their WhatsApp group, because Soma, I know they have a group for this. I can just share a script and we'll have a session with him later. Thank you so much, Soma, for the question. So thank you, everybody. Eileen Magero, how are you?
Hello, I'm quite fine.
I know it's very late where you're calling from in Kobe, Japan. Thank you so much for making the time.
It's my pleasure. I've learned a lot today. I'm looking forward to exploring the notebook.
Thank you so much. I know next week we'll have a presentation from you, hopefully, or something on water.
I will let you know.
Okay, thank you so much. No pressure.
Thank you.
So thank you everybody for joining us. Sorry if I didn't let you talk. We are together in spirit, and let's keep this momentum, and big clap for presenter Brian. And